Hello there and welcome back. Today we're going to take a look at some applications of area and volume from the actual AP exam. So we're going to take a look at a couple examples. We're going to look at the 2011 AP question, and we're also going to take a look later on at the 2012 area and volume question, which is kind of an interesting one there, especially this part C that we will definitely be spending some time with. Alright, but first let's go ahead and begin. Now normally in the AP they're going to give you an area volume question, and they'll also give you the graph. So you don't always have to worry about graphing it. And this one's nice because they also kind of gave you the domains. So let's see here. So they're telling us let R be the region in the first quadrant enclosed by the graphs y equals 8x cubed. Now they're not going to tell you exactly which one it is, but you should recognize this as f of x, this bottom one. And then they say g of x is the sine of pi x. And of course that's going to be our top function right there. Question 1 says, write the, oh my gosh, there it is. Write the equation of a tangent line to the graph at x equals 1/2 for f. So we're looking at the tangent line for f. So for part A, this should be pretty easy. So let's see, to write the tangent line, two things we're going to need. We need a point for a tangent line, and they give us the point 1/2, 1. They tell us that right there. And we also need the slope. Well, to get the slope, that's from our derivative, and that's going to become, whoops, let me make that next, 24x squared. Now, how does the AP grade this? Well, we'll go over how the AP will score this in just a few moments. But right now, let's go and find our slope. So therefore, the slope is going to be the value at 1/2. The value of our derivative at 1/2, and that's going to become 24 times 1/2 squared is 1/4, and we get 6. So our tangent line, y minus 1 equals 6 x minus 1/2, and there is our tangent line. So how does the AP grade this one? Well, let's take a look here. You will get 1 point for finding the slope, and then 1 point for your answer. So that's worth 2 points right there, and that didn't take us very long to do. Alright, so part B says find the area of R. Okay, so now we're getting into our area. So we want to find the area of this region. So because we are in terms of x, so that's the first thing I noticed, that we are in terms of x. So I'm going to draw a horizontal rectangle. From the top to the bottom, there's my horizontal rectangle. And I'm going to blow it up. Remember, this is that rectangle of mathematics. And show this. The AP likes to see work. It looks really nice if you keep it nice and look organized. The AP really likes that. So my top function, since I'm I said horizontal. Oops. Should be vertical. Okay. So it's going to be top minus the bottom. I get lost a lot, so horizontal, vertical. So vertical means up and down, horizontal sideways, because we are in terms of it should be vertical. I said horizontal there. I apologize for that. But so what we're going to do is we're going to take the top function, which is the sine of pi x, to get my height, the sine of pi x minus 8x cubed, right there. To write our area equation then, all we would have to do is to multiply our sine of pi x minus 8x cubed, our length, times our width, that dx. Remember the dx because that's the skinny part down there at the bottom. Now this is going to find the area of one skinny little rectangle. But now what we have to do is find the area of all of those little rectangles as this rectangle goes from right to left. And it's going to like kind of fill in that little region right there. And to do that, we are going to integrate. Remember, the integral sign adds up an infinite sum of rectangles. And we would evaluate that from 0, x equals 0, to x equals 1/2 to where they meet. Now, they do ask us to find the area, so we do have to evaluate this. So the first thing I'm also going to notice is that this part right here is my u substitution. I would let u equal pi x. Du would be pi dx, so dx would be du over pi. And this is telling me for the first one I'm going to divide by pi. So if I evaluate the integral, I'm going to use that shortcut. This is really, remember, u here, if we want to think about that. The antiderivative of sine is negative cosine. So that's going to give me negative cosine of u, which is pi x. But don't forget we're dividing by pi, so I should put a 1 over pi there. And then minus, and now I can do this 8x cubed. And if we integrate that, that just becomes 2x to the 4th. And we would evaluate that from 0 to 1/2. This is a tough antiderivative right there, so be careful. Applying the fundamental theorem, f of 1/2 minus f of 0, and we get, plug in the 1/2 here, negative 1/2, whoop, that's negative 1 over pi, there you go, I changed 2 to a pi, cosine, be careful, pi over 2 minus, remember this becomes right here, 1/2 to the 4th is 1/16, so that becomes minus 1/8, and then minus, plug in the 0. Well, cosine of 0 is just 1, so this just becomes minus 1 over pi, and that becomes minus 0. You do expect you to simplify. They do expect you to know what cosine of pi over 2 is. That's 0, so this becomes negative 1/8 plus 1 over pi. And there is our antiderivative right there. All right, this question right here is worth 4 points on the AP. The reason why this is worth so many points right here is because that's a really tough antiderivative. The antiderivative alone was worth 2 points. But if you can't get the antiderivative correctly, you can still get a point for your answer. So do the best you can. Not too bad to do. All right, so let's take a look at part C now. Now, part C, it says write, but do not evaluate, my favorite phrase in math, an integral to find the volume of the solid when r is rotated about the line y equals 1. Ooh, so this is our volume of revolution problem right here. So there it is. So there is my y equals 1, and I want to revolve it. Now, hopefully remember, so I'm going to erase this here real quickly so we can see everything. When we're solving for when we're doing volume of revolution, we have to first draw our rectangle in mathematics, which becomes our radius. So I'm going to pick somewhere on our axis of revolution, and I'm going to draw my radius. Now, we're looking at the region R. So if I start drawing, this part's going to be open. It's going to be dashed. But once I hit the start of region R, then it becomes a solid line, because that represents the part that's going to be shaded. Now, when we revolve this about the line y equals 1, you can kind of see we would get a washer. Okay, we're going to get a washer right there. Oops, sorry. So this is going to be our washer method. So I'm going to go and erase those real quick. There. So for part C, I did run out of room here a little bit. There we go. So let me see if I can just draw it like this. There. For part C, we're going to set up our washer. We have the inside part, and we have the outside part. There's y equals 1. Remember, it is vertical again because we are in terms of x, so we got dx. I have to first find the radius of my outside. Well, to get the outside radius, that is taking from the most top all the way down to the most bottom. So here is our outside. And the top is the line y equals 1. And the very bottom of the furthest is our function 8x cubed. So the radius of our outside is going to be 1 minus 8x cubed. To get the radius of our inside, that's the dashed part. There's our end. Again, it's this little rectangle here now that we're looking at. The top is 1, and the bottom is our sine curve. So it will be 1 minus top minus bottom, 1 minus sine pi x. So we're going to get 1 minus sine of pi x. Now we're looking for our volume. So for the volume, remember, would be the volume of the outside minus the volume of the inside. So we're going to get pi, volume of the outside, which is this 1 minus 8x cubed, squared dx. Remember, it's the volume of it. It's the volume, right? The volume pi r squared h, where h, of course, is dx, minus the volume of the inside, pi 1 minus sine pi x squared dx. And I can evaluate this by taking out the pi's. So I'm going to take out the pi's, and that's going to leave me with 1 minus 8x cubed squared minus 1 minus sine pi x squared dx. Forgot my bracket there. Dx. If you got the bracket, then I can hurt you. Then I can take off any points for that. All right, but now that's 1. So remember, this washer is going to go all the way from 0 all the way to 1/2. So now we get to evaluate that, all of them, add them all up from 0 to 1/2. And they tell us not to evaluate it, so there's our answer. Now, I went pretty slowly with this one, but you can see how fast you can go with these with a lot of practice. Now, this question right here would be worth 3 points on the AP. Now notice, the AP says this question should take you about 10 minutes, or 15 minutes. We did it in about a little over 10, but you could probably cut it down to about 5 to 7. All right, so I will see you in video number 2, and we'll take a look at the 2012. See you then.